Yeah. So I'm really happy that so many are here. My name is Dominik Burkhart. I'm a freelance developer, and I'm doing mobile for quite some time before I did with some reforms. And then after a lot of pain, I switched to Flutter. And as you see, if you look at the color of my hair, I have the legacy system here. Yeah? So I've seen a lot of systems in the past, and I'm really intrigued by what we can do with Flutter. Okay, it was asked before who has already experienced with Flutter? Who has experience with XP? With Rx, sorry. Why I'm here? I guess from Android or from on Android or okay. Good. Okay. Then we start. Okay. Before we go to switch to Rx, we want to have a look at. We want to have a look at Dart streams, and the nice thing is that Dart as a language for the ones that have not done anything with Flutter before. Dart is the programming language for Flutter, and Dart has as a language feature automatically streams built in. And a stream, you can imagine a stream like a conveyor belt, where you put on one end some data and it gets transported somewhere else. The thing is, like this, it doesn't make much sense because the data is just lost. That's the reason why we add at the end, I call it a trap. Something that the data packet can trigger when it's moving over the conveyor belt or over the stream. And the nice thing is that here, where we put on the data, the place where we put on the data is completely decoupled from the place where the reaction happens. It's decoupled in two ways. One, local from on where it is in the source. So you can put it in one class on the stream and react in a completely other. But they are always also separated time-wise. So the whole process is asynchronous. And this is very handy, especially with Flutter, because Flutter is all about reactivity. The UI just reacts on events. And so the idea is very clear, very near, to say, okay, let's trigger something in the UI with such a stream. In Dart, we have this, a class called stream controller in Rx. It's called a subject. You will see this. A stream controller creates a stream, and you use the stream controller to push data packets on the stream. Oh, I forgot one thing. Streams are type safe, so you have to declare which type will be transported over the stream, so you get a lot of security at that point. Here, that's how it looks in code. This is a little bit annoying warning that it tells me I did not close the stream at the end. So just ignore it. So here we set up the controller. We have the controller, and with listen, we're setting up the event handler, or the trap that I call it. And it should just print the item that it gets. It's a stream of strings. And here we put items on the stream. Now, just try for a moment to guess in which sequence we'll receive the outputs. Anyone an idea? Okay. We will see this here. This might be a little bit surprising, because normally you would expect that you see, or especially if you can use streams in .NET or in Java, you would expect to see 1, 2, item 1, 3, item 2, item 3, 4. The thing is, Dart is single-threaded. So this means it's not parallel, it's really only asynchronous. It needs any point and await or anything that gives the micro loop that the Dart engine is running the chance to process also the streams that are waiting. Yeah. So in the next example, I do something like this, that I give, after we add them, I give the chance to react. And one thing that I want to show here, that's the important thing, listen returns a subscription object, and that you should keep safe somewhere, because when you are done with a stream, you should cancel the stream over this subscription object. Otherwise, you will leak memory at this point. So if you look here at this place, we cancel the subscription. Now, educated guess what we'll see as output? Anyone? Yeah. Yeah, exactly. We will get 1, 2, 3, because here is the stream already cancelled, so pushing another item on it doesn't do anything. Another specific from Flutter, or from Dart in streams, is we have single subscriptions or broadcast streams. If you have used Rx on other platforms, you know that it's completely, it doesn't matter how many parties are listening on an observable, for example. Yeah? In Dart, it is that a stream, the standard stream, is only single subscription. That means, and I don't know why the Dart team has done this, but in my opinion, it was a stupid decision. Because not only is it that a single subscription stream can only listen by one party, it's even worse. If you cancel the subscription of a single subscription stream, it cannot listen again afterwards. And this is something I don't understand today. At least that they could have done it in this way, that you can after cancel and you can you listen, yeah. But it gives you an exception if you try it. The good thing is they have also another type of streams, broadcast streams. They don't have these limitations. You can listen with as many parties as you want, and so you don't have this problem. I guess they are a little bit less performant than the single subscription, but this shouldn't matter to us. For really, I did quite some complex apps with streams in Dart and in Flutter and with broadcast streams, and never had a problem performance-wise. Yeah. Down here you see how we create a broadcast stream over a factory constructor. Oh, I have to update the foils. We no longer need a new, if you don't notice. And you can convert a single subscription stream into a broadcast stream. But it's sorry, I don't know what is long way. But it's always better to directly create your broadcast stream at the beginning. Just a short recapitulation of the features. Type safe, async. Then, yeah, that's also a nice one. Stream subscriptions, setting up the handler, you can already do in the constructor, doesn't matter. On the other side, you could never await a function inside a constructor, for example. And, not last but not least, we can transform any async function that returns returns as a future into a stream. And this is, yeah, quite common because, for example, most RP functions for example, to do an HTTP call just is an async function with a future. But for the further processing of the result, I want the data to have a stream, so I just do a stream, and from there on, I'm in the stream world. The only thing is, and that's a down, it's a little bit not everything perfect. The async function will wait till it is completely completed before the first item comes out of the stream. So that's something you have to know. Yeah. Where does Rx fit in? It stands for reactive extensions, and what many people don't know, it was developed by Microsoft. And but the strange thing was that it didn't get tracked inside the Microsoft community. At least not for several years. Now it comes, but in other communities, other tech stacks, it was adopted and was very much used, especially in the Java world. And now we are back also in .NET after it's popular in Java and in JavaScript. Now we get back to the .NET world. Yeah. I always say it can be seen as streams on steroids. And as I said before, Dart includes already streams, so they did not implement the stream logic from nothing. They added the Rx functionality on top of the Dart streams. Some differences. We have a different nomenclature. Streams are called observables, and stream controllers are called subjects. That's the main difference when you read the code. Nice thing is subjects they are broadcast by default, and we have another subject, it's called behavior subject, that has the feature that it stores always the last reserved data packet. This means if data packet comes in and you start listening, you will get this last data packet. When now a second party starts to listen, it also gets this latest data packet. And this is a very nice feature when you think about the way Flutter rebuilds its UI. So if you have, shortly see there's a screen builder, and if you once got an item, and it takes some time till the next item comes, but your UI will rebuild, it's good that they get the last item again, so that your UI stays the same. One nice thing is also, as different subjects to stream controller. In stream controller, the stream interface is a property of the stream controller. On subjects, it is the subject itself is implements the stream interface. So you can listen directly on the subject, you don't have to go to the stream. Yeah. Now why do we do this? The nice thing is what we can do with Rx, or with some stream functions too, is that we transform or manipulate the data on the fly while it's moving over the screen. I have a very easy example. This is the map operator, and it's just put before the listen, so this gets a chain where the data is pushed through the map and then gets to the listen. So in this case, we see this result, or this will be the output for this. Also, I did this here, this code with Dart test, and to give the stream a chance to get into work and do that to its output, I always put this future delay at the end. This is the only reason why it's there. But we can do more. For example, we can use it to wrap one object type into another, or convert one object type to a completely different one. Let's see a little bit. Now it gets a little bit more complex, or a little bit more complicated. Let's assume we get user data as JSON from some REST endpoint. Yeah. So we have our user class. I have a very simple from JSON method. Normally I wouldn't do this manually, but use some of the JSON serializer code generators. And now the interesting part is down here. We have our, this here will be the HTTP core. We convert to a stream. We map, we want as a result the user object. What we get is a JSON stream from the stream. So in our map function, we create from the stream a user. That means from here we have a user object, and we can listen to it and do anything that we want with it. And the nice thing is, with all the Rx stuff, you really read it like you read text, and you see exactly what is happening, because it shouldn't have any side effects. It's really completely in this chain. If you see here, you see directly the comparison. The same functionality once as using Rx, once traditionally with await. And at least for me, or at least if you get a little bit used to the notation, this here is more concise and very clear what it's doing. I admit you have to get a little bit used to it, to this form of programming, and also to get used to it. That, for example, just one step back here, that this part here is not executed until the first object comes in. Yeah? This is one of the things I remember when I started with Rx that made really, I didn't understand at the beginning. How if I write a listen and a handler, and why isn't this executed? Yeah, this was something. It really requires a little bit of shift of thinking. Streams in Flutter. Flutter is when the designer of Flutters were aware how good streams are fit for Flutter. So we have a stream builder. And just again, because I didn't see it before, who has nothing done with Flutter yet? Okay. This here is a typical example of a build function in a widget, and it is executed when the UI is rebuilt. Yeah? So, and this build function returns a widget. And this widget is called Stream Builder. And the Stream Builder has the nice feature that it will build, it has here a builder function, and this builder function will get called every time the string that I pass here gets a new package. And this is really nice. So, for example, I have here in the following, I have to check if the snapshot that I get when the packet arrives, I have to check, has it really data? And no, the data is not zero. It could have an error, for example. And then I return, every time I get a new package, I return a new list view with the data of this package. This is something, if you haven't done Flutter before, this reactive rebuilding of the UI is also something you have to get used to it. It's really, on every new data package, we completely rebuild this list view. We do not add or remove any elements of the list view, we just rebuild it with new data. And Flutter is fast enough because the core is written in C++, it's a Skia engine, and even also Dart when it's compiled is really fast. So it's not a problem, but you have also really to get used to this thinking. We just provide new data and trigger a new rebuild. It's created with a builder. This means for every list item, a builder function will be called with the index. And in this case, this calls a function build row, for example. This will then create a widget for this specific list item. Then the thing is, stream builders are also type safe. This stream builder, for example, expects that the items that the data packet that it receives are lists of weather entry. So with this, the list view builder here can very easily work. Here the data is the list of weather entry in the snapshot. It gets the length for it, and it can then correctly pass the data that received this, to the build row function. Was this halfway understandable for the completely Flutter newbies? What happens there, or it's difficult? I don't know. Okay. You know, it's pretty easy. As far as nobody says something, I think everyone has understand it. Yeah. So it's your problem. Another example, another operator on the Rx chain. Typical requirement: you have search box where the user can type in characters, and with new values in the text box, you make a REST call to receive the latest search results. Now, it's not really ideal while the user is typing that you make a call on every character. It makes much more sense to make the call the moment the user pauses for a moment. And for this, we have a debouncing function operator on the Rx. I have here, for example, I just call it debounced user input model. What do we have here? We have one input subject. To this subject will the data from the text field be pushed in. We have a result subject. On that, for example, can a stream builder listen to get the result from the search. The on-search text chain is the concrete handler that I pass to the text field unchanged, and this doesn't anything else than push the latest value from the text field into the input subject. And here, that's interesting. The input subject we want to do with the data is something that's coming on. And now the debounce operator has the nice thing, it won't let any data down through until a pause of the given duration. And you don't have to do anything for this. Then, in this case, I make I train another function for this, an async map with the search text. Async map is able to make an async call inside this chain, and I get back some result, and the result is added to the result subject. And this is completely self-contained. And at least for me, or maybe you will agree with me, that if you read this, it's very clear what's happening. If you write the same debouncing with imperative code, traditionally you have to set a timer, you have to react to the timer, you have to clear the timer. It's not so easy to directly spot what's going on. Then we have a merge operator. Merge allows to merge from multiple input streams, or input observables, to be correct, into one output observable. Without any specific ordering, they are just pushed out as they come in. And how could this look like? This is a little bit pseudocode. It's not a real code. Let's assume we have some async function, that's already a stream, some function that returns a stream of Twitter Twitter posts. The same from Facebook. We map them to get our own objects, and the post stream that we have is then this two we merge with the other stream, and on this stream we get then all packets that come in. Now, I don't know, who of you have worked with Firestore? Yeah. Firestore is the document database from Google in the Google Cloud. And one nice feature of Firestore is that you have collections of documents there, and you can listen over stream. What a surprise! You can listen on changes on these collections and react on this. So we can directly plumb our Rx onto the database and do something with the data. In this case, let's assume we have some news website. We have one field with news and another field with web data. Now, I could do this with two separate screen builders, but let's assume we want to have one screen builder that updates both of them. And I have these two collections in Firestore. We use another method that's called combine latest. And combine latest waits until it has an input from both sides and pushes them out. That's not really correct. It will push out the latest value that comes in, combined with the last value it got before. Yeah. Just a moment, following the animation, then it gets clear, I think.
No, tak myślę, że tak
Oh, just again. Okay. One comes in, nothing comes out. Two comes in on the other side, nothing happens. Well, now we get the first combined one. The two comes in, now we get this one. And this is a very handy operator in a lot of situations. Wait. The last one? No. It waits till the first one comes from the... Wait. This should... Wait. Oh yeah! You are right! the animation.
Actually, 2 is the latest one. Number 2 is the latest one on the street.
Yeah, right. But the thing is, the first one was completely forgotten. This shouldn't happen. Hey, someone who's really listening and looking. This is cool. I really like it. How would this look like in code? We have a better entry, news entry. Both have deserialized function with mapping. We have a news aggregator object that contains both data from both sides. Then we have our Firestore collections, weather collection, news collection. And now it gets a little bit wild. I could have done this in more steps, but if you follow me, perhaps we manage it. I return an observable of news aggregator. On this can a stream builder listen. Now, we do an observable combine latest to. This is a little bit a disadvantage of Dart. Dart has no operator overloading. So we have to, if you have methods with 1, 2, 3 parameters, we have to somehow either number them or give them different names. Now somebody might think, hey, but why not pass an array of observables? The thing is, combined latest can work on multiple types on the different inputs. So we can't use an array in this case. We use combined latest too in this case because we have two streams, and we do it cleanly typed, the 2 input streams and the output stream, the data type. And we pass in weather collections snapshots. This is the stream to the weather collection map. We create we get their called document back, document collections documents. Then we map this to a weather entry and convert it back to a list because it's just iterable what we get back from the map. The same thing we do. We pass a second parameter, the news collection, map it to a news entry. And return in the end, we get as third parameter a handler that in this kind is a lambda function that gets the results from this too and returns this object. But as seen in the animation, it won't output anything until it received on both streams at least one object. Yeah.
Will you show those decks because people have to just think what you see?
What do you mean?
Will you start those decks?
The slides. Yeah, it's not a problem. And also we have I hope it works. We make video. Yeah. Yeah, we figured out the first one. I lost the first element. It's a bug in the animation. This gets lost. This shouldn't be. Yeah. Actually, if you wonder how I did these animations, I was really searching for a simple animation tool, and there's almost nothing on the market. So if you need a new niche where you place a product, do a cool animation tool for something like this. This is done with PowerPoint. And I only can tell you, PowerPoint animations are horrible. To change they have events and emphasize things, but it takes a lot of time. And even worse, I had a hard disk crash in between, and I lost the original PowerPoints. I have only the GIFs at the moment. And I didn't want to recreate them again because it's really a shitty job. Okay. Yeah.
So I was thinking, if let's say one emits a stream and the other doesn't.
Yeah.
Does he, from what I've seen in YouTube, emits the latest one and the last one goes, and the last one goes.
Okay.
Must he always do that? He can't emit one stream.
It is one combined stream, one stream with an object that combines both data. From two streams, you get one result stream. Yeah.
Okay, let's say I emit.
Wait,
So can you? Okay, yeah. Like for example.
yeah. Forget the one.
Okay, so.
Two gets in, nothing comes out.
Now,
The one, then it gets out.
so 2 comes out, right? And it goes with 2.
Because the last, it has a value from last value from the other input, so it can create a new pair to push it out.
Okay, so that's what I'm saying. 2, it must always combine 2.
Yeah. Exactly. This is why it's called combined latest, this operator. Yeah. Actually, there is a combined latest 3, 4, 5. So if you have even more, you can also combine them into one. Which is different if we have what we have seen with merge. Merge, for example, just pushes directly out what comes in. Yeah. And yeah, this were only, I think, 3 Rx operators that we had a closer look on. There are many, many more. And many, many more complex. And even, although I give the talk here, I wouldn't call myself an Rx wizard, not at all. There are some functions where I still wonder, what would you do with them, and how do they work? Yeah? But the message that I want to bring over with this is, it doesn't matter if you are completely screen wizard or Rx wizard. Just start with the basic operations, like the ones that we've seen here, and they are really easy to use. And then have a look on what other operators are available, and see, oh, okay, perhaps this looks handy, have a closer look. That's, in my opinion, the best way to, really to learn Rx. Getting a book with all the operators, reading this. There's also one website. It's really good to look up things, but you are overwhelmed and you don't have context. And this was at least my goal with this talk, to put it into some context, get an idea. Okay, how could I use this in my projects? And we have seen it's a very concise, clear way how we express what our code should do. It's really a perfect fit to the reactive rebuilding, because really items comes up, rebuild. And the nice thing is, a screen builder rebuilds only its child. Yeah? So this means if I have the whole screen, I can have multiple screen arenas, screen builders on them for different parts. And if they get a new image, a new data package, only this screen builder will be rebuilt, not the other areas. So you can do it very clearly. Also, you can do, for example, I didn't have shown you this, for example, also there's a where operator, where you can filter what data comes through here. So, for example, if you have two widgets on screens that actually need the same data, but for example, one needs only wants some status, the other one wants the actual data. For example, the one should just tell you, okay, there is some new data, you want to show this. Then you could take the same source screen, the source of the observable, and listen twice on them. On one of them, you could map the received value to a stream of pool, for example, and with this you could, for example, change a red or green flag on your UI. And the second time, you listen and push this to another screen builder who then displays the data at home. So you are really very flexible and can do a lot of this. And especially, for example, with the where or with the where, for example, just easy. Just one example. I have a UI with two lists, and I have names coming in, and I want to have all the numbers coming in, and I want to have all the even numbers on the left list and the odd numbers on the right list. Yeah? So I take two screen builders on each side. I have the input stream where the where numbers comes completely unsorted, and now I listen on this stream. Perhaps try to follow input stream where x is odd, and take this to one screen builder, and the other one where x is even, and return this stream to the other screen builder, and you are done. Yeah, and at least for me, it's a very elegant way to transport data through your application. Yeah, more resources. I have 2 blog posts on this, and yeah, perhaps just if you easiest way to take a picture. So if you want to, but we will make this available, and for a deeper dive into it, these 2 sites, they are really good, but they are really, I would say, hardcore. Yeah, there you find all the operations. And you can find myself on Twitter under this handle. Questions? Yeah?
You said...
Wait, I come to you.
In the beginning, you said that when we make subscriptions and we don't unsubscribe, that we have memory leaks. Now, does Flutter have any abstraction where we can automatically unsubscribe from widgets without us always having to manually unsubscribe, because we might forget to unsubscribe if you have a large code base?
That's a really good question, and unfortunately, no, because Dart doesn't know destructors. And it is really a weakness. And I asked the Dart team what's the reason for this. And the reason is Dart can not only be compiled to mobile apps, you can also transpile it completely to JavaScript. And this compatibility should not change, and JavaScript doesn't know destructors. So they can't do this. The way we have to do it, the nice thing is if you use a stream builder, you don't have to care, because the stream builder does the subscribing and unsubscribing on its own. That's you don't have to care about it. And you can use a stream builder inside a stateless widget without problem. The stream builder itself is stateful and handles everything. If you want to listen on your own on the streams, which can completely make sense. For example, if you have one screen that just assume you have a network service where you want to get the actual status of the network pushed out over a stream, and you listen with stream builder. You could listen with a stream builder on this, but maybe you want not only to display something, but to do some other things. So in this case, typically you start listening on a stream in the init state of a stateful widget function, and you dispose the subscription in the dispose function of the stateful widget. But you have to take care yourself on it, that you don't forget one. Yeah?
I think that Flutter hooks may be helpful in this case.
I think that Flutter hooks library may help you because you can write a hook once for such case, and also it has default hooks for value listening or something like that, and it disposes some listeners itself, or you can write a hook and do it once, maybe.
This could be a possibility. I'm not 100% sure if you can do it in a generic way for every stream that you use, because you would at least have to then to pass this the stream that you want to dispose in the, later. You have to pass it into hooks somehow. I don't think we change a lot, because if you forget one of the streams to hand over to hooks, we didn't win much. Honestly, this is just my personal opinion. I'm not a big fan of hooks or of provider, because I prefer to go all streams. So I don't know if you have seen it. I have a package out there. It's called Get It. It's a service locator, an extremely fast service locator. With that, you can directly access your registered models or services from the UI, and I go directly on this in the UI and access this over the screens. Yeah, so I don't use providers or hooks in this case, but that's a matter of taste. I would say how comfortable are you with screens, and yeah, what you prefer. Okay. That was it for today, for this evening. Thank you.